Hello students, and welcome back to part 2 of lesson 3. We are going to be looking at 3 more examples and then looking at the last rule. So in this problem we see powers of powers, and we learned that if you have a base to a power and that amount to a power, we can multiply the powers together, giving it the same base. So if we have 3 to the 4th to the 5th power, that will be the same as 3 to the 4 times 5, which is 20. So the simplified expression is 3 to the 20th power. Let's try 6 cubed to the negative 1 power. Again, the base will stay the same and we multiply the exponents. 3 times negative 1, which is negative 3. So we get 1 over 6 cubed. Let's try one more example. We have a cubed to the 4th power times a to the negative 2 to the 10th power. So we see the same property, powers of powers, 2 times. A cubed to the 4th power will equal a to the 3 times 4, which is 12, times a to the negative 2 to the 10th power. We get a to the negative 2 times 10, which is negative 20. Now, we have simplified powers of powers, but now we have the product of 2 powers. So we will have to add the exponents. A to the 12th times a to the negative 20 is equal to a to the, and we'll have to add it, negative 12 plus negative 20 makes negative 8. If you have 12 and you owe 20, you owe 8. Now this is more simplified, but now we have a negative exponent, so we're applying the rule that a to the negative n is equal to 1 over a to the n. So this is equal to 1 over a to the 8th. Now let's look at rule 3. Rule 3 is the power of a product property. If you have a this is used when you have a multiplication expression to a power. So you could say a product raised to a power equals the product of each factor raised to that power. Let me show you an example. If we have 2 times 4 to the 3rd power, we could say that we have 2 times 4 times 3 times. So we have 2 times 4 once, twice, 3 times. Now if you look, the commutative property says you can move these numbers in any order. So let's put all the 2's together. 2 times 2 times 2 and 4 times 4 times 4. So that is equal to 2 to the 3rd power, because we have 3 of them, times 4 to the 3rd power. And you can see a shortcut is each factor in the product gets that exponent. We get 2 cubed and 4 cubed. Algebraically, this property is represented this way. If you have a number times another number and it's to a power, it'll always be equal to the first factor to the power times the second factor to the power. Let's do an example. In the first example, notice the parenthesis is inside. So we have negative 3x, all of which is squared. So when we square the negative 3, which is our first factor, we'll have to keep it in parentheses. Negative 3 squared, and then we'll give the x the square, x squared. That is your simplified expression. Now notice in this one the negative is outside, so we'll just carry it along. So we have a negative and then we have 3x squared. So we'll have to give the square to the 3 and to the x. So we have 3 squared x squared. Notice when the parenthesis was inside, it stayed inside a parenthesis, so that the whole thing was squared. But when the negative was in front, it just remained in front because the negative was not being squared, just the 3 that was inside. Now, this property can be combined with other properties. Here you see 2 factors. to a power. So this is still the product of a power of a product property. We're going to have to give the exponent to each of the two factors. So we have x to the negative 2, and we're going to have to use parentheses because now we have to give it the power of 3. So you see the power of powers property times y squared to the third power. All we did was give the exponent to each part. That is the power of a product property. Now, we are more simplified, but we can simplify further. We have powers of powers, which we know means we multiply the exponents. So we get x to the negative 6 power times, and we have again power of power, we get y to the 6th power. Now we are more simplified, but we have a negative exponent, so we're going to have to move that to the denominator. Since y to the 6th has a positive exponent already, we'll leave it in the numerator and put it over x to the 6th. So our simplified expression is y to the 6th, x to the 6th. When you get a lot of practice, you may be able to skip writing this step. But for now, go ahead and write it as you practice. We have 4 times p to the third power. So we're going to have to give the third power to each part. So we'll have 4 cubed, p cubed. And that's our simplified expression. All positive exponents. Alright, let's try negative 5t squared, all of which is to the second power. Notice the parentheses inside, so we're going to need parentheses around that. So we're going to give the square to each term inside, to the negative 5, each factor inside, to the negative 5 and to the t squared. So we'll have negative 5 squared times t squared squared. Now this is a simplified expression, so we'll carry it along. But here we have a power of a power. We know that a power of a power means we multiply the exponent. So we get t squared squared, which means t to the 4th power. And here's our simplified expression. Let's try one more example. This one is going to combine all 3 of the properties that we learned today. So we have x squared y to the third, all of which is to the 4th power, times x squared y to the 4th, all of which is to the negative 4 power. So we have to get, let's start here with this one, we have to give the exponent to each factor. So we get x squared to the 4th power, y cubed to the 4th power. Now we're going to have to do the same thing here because we have a power of a product. We're going to give the power to each factor. So we'll have x squared to the negative 4 power and y to the 4th to the negative 4th power. Now we've simplified the power of a product, but we now have powers of powers. So we have to multiply those exponents to simplify. So x squared to the 4th is x to the 8th. 2 times 4 is 8. Y cubed to the 4th power is y to the 12th. 3 times 4 is 12. X squared to the negative 4th power is x to the negative 8 power. 2 times negative 4 is negative 8. Y to the 4th to the negative 4th power is y to the negative 16 power. Now, notice we have 2 bases of x being multiplied. So we can use the product of powers property to combine them by adding the exponents. So x to the 8th times x to the negative 8 makes x to the 0 power. 8 plus negative 8 makes 0. Y to the 12th and y to the negative 16 also have the same base. So when we combine them using the product of a power property, we get y to the negative 4th power. Now, x to the 0 we don't have to write because that's 1, and 1 times anything is just itself. So we have left y to the negative 4. Since it has a negative exponent, we'll have to move it to the denominator to be y to the fourth. So our simplified expression is 1 over y to the fourth. So to summarize our three rules, we had the product of powers property, which says if you're multiplying two powers with the same base, you can add the exponents. We had the powers of powers property that says if you're taking a power of a power, you keep the same base but you multiply the exponents. And last, we learned the power of a product property. If you have two amounts being multiplied to a power, then it's the first factor to the power times the second factor to the power.